Welcome to this introduction to Solidity. Solidity is the primary programming language used to build applications on the Ethereum blockchain. Think of it as the tool that brings blockchain technology to life by enabling developers to write smart contracts. Throughout this video, we'll explore what makes Solidity special and how it powers decentralized applications. Solidity is a high-level, object-oriented programming language specifically designed for writing smart contracts on the Ethereum blockchain. It's statically typed, which means you must declare variable types before using them, helping prevent errors. The syntax is similar to JavaScript and uses curly brackets, making it familiar for many developers. When you write code in Solidity, it compiles down to bytecode that runs on the Ethereum virtual machine, or EVM for short. Smart contracts are the heart of blockchain applications. They are self-executing programs stored permanently on the blockchain that automatically enforce and execute agreements without intermediaries. Once deployed, smart contracts are immutable, meaning they cannot be changed. They are distributed across the entire blockchain network, ensuring transparency. Most importantly, they are trustless, meaning parties don't need to trust each other because the code itself guarantees execution. Let's look at a basic smart contract structure. Every Solidity file starts with an SPDX license identifier comment, which specifies the license for the code. Next comes the Pragma directive, which declares the Solidity compiler version. In this example, we use version 0.8.0. The contract keyword defines the contract itself, similar to a class in other programming languages. Inside the contract, we can declare state variables like message, which stores data permanently on the blockchain. The constructor function runs once when the contract is deployed, initializing the message variable. Solidity offers various data types divided into two main categories. Value types include bool for Boolean values like true or false, uint for unsigned integers, which are always positive, int for signed integers that can be positive or negative, and address for storing Ethereum wallet addresses. Reference types include string for text data, arrays for storing collections of elements, struct for creating custom data types, and mapping for creating key-value pair associations similar to dictionaries in other languages. Functions are the building blocks that define the behavior of smart contracts. The setNumber function is a standard function that modifies the contract state by updating a variable. The getNumber function is marked as view, meaning it only reads data without changing anything. The calculate function is marked as pure, which means it neither reads nor modifies the contract state and works purely with the parameters passed to it. Each function specifies its visibility and return type clearly. Function visibility determines who can call a function. Public functions are accessible from anywhere, both inside and outside the contract, and can be called by other contracts or external users. Private functions can only be called within the contract where they are defined, providing the highest level of encapsulation. Internal functions can be accessed within the current contract and any contracts that inherit from it. External functions can only be called from outside the contract, making them ideal for interfaces with other contracts or users. State mutability keywords describe how functions interact with blockchain data. View functions can read the contract's state variables, but cannot modify them. When called externally, they don't cost any gas because they don't change the blockchain. Pure functions are even more restrictive as they neither read nor modify state variables, working only with the parameters passed to them. Payable functions are special because they can receive Ether along with the function call. Any function that needs to accept cryptocurrency payments must be marked as payable. Events are an efficient way to log information on the blockchain that external applications can listen to. They are declared using the event keyword followed by the event name and parameters. Events are particularly useful for notifying external applications about important state changes in the contract. When a function executes, it can emit an event using the emit keyword. In this example, when tokens are transferred, the transfer event logs the sender address, receiver address, and the amount transferred. External applications can subscribe to these events and respond accordingly. Let's cover some essential concepts you'll use frequently. Message.sender is a global variable that returns the address of the account currently calling the function, helping you identify who is interacting with your contract. Message.value contains the amount of WAY, the smallest unit of Ether, sent along with the transaction. The constructor is a special function that executes only once when the contract is first deployed to the blockchain, perfect for initializing contract state. Modifiers are reusable code snippets that can check conditions before a function executes, commonly used for access control and validation.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.